All right, so this is our first time trying out a little video teaching. So I hope this works well for you. I miss you guys. Hope things are going well. Um, Today we are looking at molecular geometry, and I pulled out the 4 pages from the PowerPoint notes and submitted those to you in Google Classroom, so it makes it easier. But you see the steps to determine a molecule's geometry or shape. Same thing, two different words. Like I said, a lot of things that have two different ways of saying it, but a molecular shape or a molecule's geometry, same thing. And so if you'll look at your notes from this, you see on the first page of the notes, it tells you that the steps to determine the Vsepr, or what's commonly called Vsepr, to determine the shape is you want to first draw the electron dot diagram. And so here we have our molecule, which is CSE2. And so first thing we got to do is, in order to draw a molecule on the dot diagram, first thing you have to do is determine which one is your central atom. And the central atom is always going to be the capital letter, or obviously the element that is all by itself. So in this case, our carbon is our central atom. Now, if you have carbon in a molecule, it is almost always going to be the central atom. If it's in that molecule, it's going to be the central atom. But also just the one that's all by itself. That's the one that's going to also be the central atom. So we're going to go ahead and we're going to draw the carbon. We know carbon is in the center, so we'll go ahead and put our C in the center. We're going to do Lewis dot diagrams here in the top box, and you see we'll do bond formulas down the bottom, and you see that's written. That's the separation here. So carbon, you go over and look, find it in your periodic table, and you see that it has how many electron dots will it get, or in other words, valence electrons? Well, it's in group number 14, so that means it has 4. 1, 2, 3, 4. Remember, you just put them around there one at a time. So it has 4 valence electrons, or 4 single electrons. And then it's going to also bond with Se2. So this is selenium, and there are 2 of them. And so selenium, we look it up. We find it in group number 16, which means it has 6. So remember, 6 means 1, 2, 3, 4, 5, 6, where carbon was. You can put the single ones over here just so you can see them, so you know how to put them together out here. But so we know that selenium, put it here, and we have a single. We know we have 2 single spots, and we know we have 2 pairs of electrons. Okay, and remember, these are called lone pairs, but remember, singles are always going to bond. So we're going to go ahead and circle those. We have another selenium. Go over here. Single, a single, pair. Those are going to go together. All right. And so here is our bond diagram. Now, our Lewis dot diagram. Now, what we want to do then is redraw this and just show the bond diagram. So remember that bond diagram simply replaces the circled, or the pairs that are shared. It just replaces them with a line. So we have 2 lines going here, and we have 2 lines going here. Okay? And then we look and see, only on the central atom are there any lone pairs on the central atom. Well, on this carbon, we see that all of our electrons were singles, and so all of them ended up sharing with another single, and therefore we have no lone pairs around the central atom, which is carbon. Okay? So now we're simply going to add up. How many lone pairs did we have in this structure? On this central atom, we had none. No lone pairs on the central atom. Okay? Doesn't matter about these out here. Okay? Only the central atom. How many atoms are bonded to the central atom? Well, we had 2, which are the 2 seleniums. 2 plus 0 is 2, which then that allows us to figure out what is the basic shape. So when we look in our notes, how many domains? This is what is called a domain. Right? There are 2 domains in this one. And if you look at the second page of the notes, you see anything with 2 domains has a basic geometry shape that's called linear. Or in other words, it's in a line. And you see the line right there. Now, we also want to label, are these bonds single, double, or triple bonds? Well, we have 2 lines, so we know that's a double. Now, so we know those are double bonds. Both of these are double bonds. That's a double, and that's a double. All right? Now, when we go down and figure out the molecule shape, then we know this is the basic shape, or the electron shape. In order to find out the molecule shape, we need to ignore any of the lone pairs in our diagram. And we don't have any, so we don't have to ignore anything, and that means that the shape is going to be exactly the same. So this is also linear. Now, what are our angles? What is our angle here between each one of our atoms? Well, in this case, there's only 2 atoms that are bonded to the central atom, so they're going to get as far away from each other as possible because they both have electrons around them. Electrons are negatively charged, and negatives are going to repel each other. And so that's where this whole valence shell electron pair repulsion, this Vsepr, that's where it comes from. The whole idea is the electrons are going to be pushing away from each other. So they're going to get as far away as possible from each other, which, as you look on the diagram, that means this angle is 180 degrees, which is what we'll put right here. Now, that completes then for this one. What you're going to do is use the link that I gave you to the PhET, and you can draw them there, or you'll need to draw them here, and then put how many atoms and how many lone pairs you have. You need to just put those on into the system, and it'll show you the names. And so that is how you will find. That's how you'll find them. You can also use the notes, page 3 and page 4. I have specific directions on what each one of them is. And so those descriptions will help you decide whether or not the shape, the molecular geometry, is either a linear, a trigonal planar, a tetrahedral, a bent, or a pyramid. So it can be any one of the 5. The molecule shape can. The basic shapes you'll notice on page 3 of your notes, you'll notice there's only 3 basic shapes that we're going to be looking at. That's the linear, which just means they're in a straight line. A trigonal planar, which means there's there's a atom in the middle, central atom, and it has 3 things bonded to it, which we don't have in this one, obviously. But that's a trigonal planar. You'll see that on page 3. And then a tetrahedral. Obviously 3. Tetra, 4. So in a tetrahedral, that's the one that has a central atom with 4 atoms bonded to the central atom. All right. When you get over if they do have lone pairs, that means the molecule shape is going to be different than the electron shape or the basic shape if it has a lone pair. Notice there's only 2 different lone pair shapes that we will have. It is bent, That means there are 2 atoms, and then there's also 1 lone pair or 2 lone pairs. There's lone pairs, and then there's only 2 atoms. That's going to be a bent shape. Water is a great example of a bent shape. And then you have pyramidal, which is the central atom with 3 atoms bonded to it and 1 lone pair. And you can see that there on page 4 of your notes. All right, I think that gets us a good start. I'm going to walk through here the second one with you. I want you to go ahead and write our central atom, which is going to be our central atom. Yep, the AS. AS is going to go in the center. Right? If we took and we wrote AS, we look it up, we find it on the periodic table. That's arsenic. It's in group number 15. That means it's going to have how many electron dots around it? 5, right. So we go 1, 2, 3, 4, 5. Then H, hydrogens, they are in group number 1. So they're going to have 1. All right. So we're going to simply go over here. We want to draw that. So if we put our AS, I'm going to put my lone pair down at the bottom, put my singles up here. And so these hydrogens are going to go, obviously, with each one of these. All right. You redraw that. So that means you're going to draw everything exactly the same place it is. But instead of doing circles, you're going to put a line for every circle that you have. So that's just single lines. That means these are all what type of bonds? Single bonds, right. Not triple bonds. There's 3 different single bonds. They're all singles. They're not 3 circles going to the same atom. Okay? All right. Now we'll go up. How many lone pairs are on our central atom? Oh yeah, there's 1. Cool. How many atoms do we have bonded? 3. Good job. 3 plus 1, 4. 4 is how many domains we have? 4 domains. Which one is it that has the 4 domains? Well, 4, remember, is tetra. 4 and tetra, so it's tetrahedral. Okay. Now, that's the basic shape is tetrahedral, but now for the molecule shape, you have to ignore the lone pairs on the shape. So we're going to ignore how many? 1. Tetrahedron without one of its atoms, because it only has 3 atoms. One of them's a lone pair. And so that's going to be 3 atoms, 1 lone pair, and you see that is called pyramid or pyramidal. And it's actually called trigonal pyramid. Okay. And then what are the bond angles for tetras? Yeah, they're 109.5. All right, well, that gives you a couple of them there to allow you to see them. If you have any questions, definitely post them in the comments on our classroom page here, and I will answer them. All right, hope you're doing great. Talk to you soon. Bye-bye.